These engines were still pulling 80,000-pound loads past 1,000,000 miles on original blocks, original cranks, never opened. While today's fleets schedule engine rebuilds every 500,000 miles and budget for electronics failures quarterly, these iron block diesels just kept running. No sensors to fry, no emission modules to detune them, no software updates required, just mechanical injection, cast iron, and the kind of obsessive over-engineering that the trucking industry built its entire golden era on. Number 10. 1966 to 1987. Mack R Model. If there is one truck that defines the American working-class semi of the 1960s and 1970s, it is the Mack R Model. Introduced in 1966 as the direct successor to the iconic Mack B series, the R Model was a Class 8 conventional cab truck that would go on to become one of the longest-produced commercial trucks in history, running continuously for nearly 40 years until the final variants were discontinued in 2005. But the story of the R Model's endurance begins with the engine that powered its launch, the Mack Maxidyne ENDT 675. Mack introduced the Maxidyne in 1966 for the 1967 model year, and it was not a modest evolution of previous technology. It was a calculated gamble. In 1966, Mack was facing serious financial pressure and was struggling to compete against Cummins, which had grown to dominate engine supply to the heavy truck industry. Mack's response was to engineer an engine that did not just compete on power. It competed on an entirely different dimension: torque delivery across the RPM range. The Maxidyne END 675 was a turbocharged inline-six diesel with 675 cubic inches of displacement, approximately 11 liters. It produced 237 horsepower, but its revolutionary feature was its torque curve. The engine was engineered to provide a low-end torque rise of up to 52% at low RPM, achieved by precisely modifying the fuel injection system and adjusting turbocharger pressure. This meant a driver hauling a loaded flatbed up a mountain grade could drop down through the gears and still find massive torque available at the bottom of the RPM band, rather than needing to work the engine hard at high revs to maintain momentum. To complement the Maxidyne, Mack simultaneously introduced the Maxitorque transmission, a 5-speed gearbox designed to work with the engine's wide torque band. The combination meant operators could run the truck in a higher gear for longer without downshifting, reducing driver fatigue and mechanical wear simultaneously. This system was remarkable engineering for 1966, and it fundamentally changed how American truckers thought about driveline efficiency. The Mack R Model was offered in a remarkable variety of configurations: highway tractors, dump trucks, concrete mixers, construction haulers, logging trucks, and steel hauling flats. The same basic cab and engine architecture that hauled timber in the Pacific Northwest also pulled bulk cement in Texas and moved steel coils in the industrial Midwest. That versatility across the most demanding duty cycles in American commerce was proven over decades of service. The R Model cab itself was an innovation in its day. Unlike the Mack B series it replaced, the R featured a one-piece fiberglass hood that tilted forward on a front hinge, providing unprecedented access to the entire engine bay. For a driver-owner who maintained his own truck, this was a practical revolution. The engine could be inspected, serviced, and repaired without removing components that had no business being disturbed. Mack built the truck to be fixed, not discarded. By the early 1970s, the ENDT 675 was succeeded by the larger and more powerful 300 series engines. But the design philosophy of the Maxidyne, high torque rise, broad power band, mechanical simplicity, defined every subsequent Mack engine of the era. R models from the late 1960s and 1970s are still found working today, particularly as vocational trucks in quarry and construction applications. The frame rusts, the cab weathers, but the drivetrain endures. Number 9. 1967 to 1987. Peterbilt 359. When Peterbilt introduced the Model 359 in 1967, the company was making a statement about what a long-haul highway tractor should be. The 359 was designed from the beginning as the flagship conventional truck in the Peterbilt lineup, a long-hood setback axle tractor built around a generously proportioned engine bay that could accommodate the largest and most powerful diesel engines available. It ran for exactly 20 years, right through 1987, when it was replaced by the legendary Peterbilt 379. In those 2 decades, the 359 became one of the most iconic and respected trucks in the history of American commercial transportation. The 359 was offered with a wide range of engine options, but 2 engines defined its era and reputation: the Cummins NTC 855 inline-6 and the Caterpillar 3406. Both were among the most durable diesel power plants ever fitted to an American highway truck, and both benefited from the 359's long hood, providing excellent cooling and easy serviceability. The Cummins NTC 855, the precursor to the Big Cam series, was available in the 359 from its earliest years. This 14-liter turbocharged inline-6 was the dominant engine in the Class 8 market through the 1970s, and for straightforward reasons, it was mechanically robust, produced reliable torque across a broad RPM range, and could be serviced by any competent diesel mechanic in North America. When the Big Cam version arrived in 1976, named for its larger 2.5-inch diameter camshaft that enabled a more efficient combustion event and reduced fuel consumption, the 359 became the truck of choice for owner-operators who understood that fuel costs and reliability were the 2 variables that determined whether a small trucking operation survived or failed. The Caterpillar 3406 became available in the 359 during the 1970s and quickly found a devoted following among drivers who prized its broad power delivery and its reputation for exceptional bottom-end durability. The 3406 was a 14.6-liter inline-6 that Caterpillar had developed from its industrial engine heritage, and it brought that heritage's engineering standards directly into highway service. The mechanical injection 3406 versions without electronic controls were particularly praised for their longevity and ease of field repair. The Peterbilt 359 cab was constructed with an aluminum hood and fenders, lightweight, rust-resistant, and comparatively easy to replace if damaged. The chassis was built from heat-treated steel rails of sufficient depth and thickness to handle years of maximum load highway service without developing cracks or fatigue failures. The truck was not aerodynamic by any modern standard, but aerodynamics were not the priority in 1967. Durability, repairability, and maximum payload capacity were the design targets, and the 359 hit all of them. In 1977, Peterbilt assembled its 100,000th vehicle, a long-hood Model 359. That milestone spoke to how central the truck had become to the commercial hauling industry in just a decade of production. Owner-operators who drove 359 trucks in the 1970s and early 1980s routinely put 1 and 2 million miles on the combinations they ran, returning time and again to Peterbilt shops for nothing more than scheduled maintenance and the occasional clutch replacement. The 359 appeared in films, country music, and the cultural imagination of an America in which the long-haul trucker was a genuine working-class hero. But underneath all of that cultural weight sat an engine and a chassis that had earned the truck's reputation 1 million miles at a time. Number 8. 1961 to 1982, Kenworth W900A. In 1961, Kenworth introduced the W900 conventional as the replacement for its existing 900 series trucks. For over 60 years, Kenworth has produced 3 fundamental versions of the W900 model family, making it among the longest-lived automotive designs ever produced anywhere in the world. The W900A, the wide-hood second generation produced from 1967 through 1982, is considered by many veteran truckers to be the peak expression of that design. Powerful, imposing, and engineered to run indefinitely. The W900A's wide hood was not purely aesthetic, it was functional engineering. The enlarged engine bay accommodated the biggest diesel engines available in North America at the time, with superior airflow and cooling compared to competing cabover designs. When fitted with the Cummins Big Cam 855, and particularly with twin-turbo configurations available to serious owner-operators, the W900A could produce power figures that were extraordinary for the late 1970s, with some twin-turbo builds delivering well over 400 horsepower from the same fundamental 14-liter inline-6 architecture. The Cummins Big Cam, 855 became the engine of choice for W900A owners who demanded both performance and longevity. By 1983, Cummins' share of the Class 8 engine market had grown to 63%, up from just 29% in 1975, and the Big Cam was the primary reason. Its demand flow cooling system, which directed cooling only to areas of the engine generating the most heat rather than flooding the entire block uniformly, was an engineering innovation that simultaneously improved fuel efficiency and extended engine component life. The Big Cam's unit injection system, driven directly by the camshaft, eliminated the high-pressure fuel lines of earlier injection designs, removing a common failure point and improving injection consistency across millions of firing events. Kenworth introduced what it called the VIT, Very Important Trucker, limited edition W900 in 1974, offering premium interiors with leather padding, sleeping bunks and amenities that were genuinely luxurious by the standards of a 1970s truck cab. These trucks were the status symbols of the owner-operator world, and drivers who invested in them expected engines and drivetrains that would justify that investment across a career of service. The Big Cam delivered on that expectation with a reliability record that made it the benchmark against which all subsequent Class 8 engines were measured. There were 900A trucks from the mid-1970s through the early 1980s that were well-maintained are still working today, 5 decades after they rolled off the Kenworth line in Renton, Washington. The cab structure, the frame, the hood, all of it has aged, but the Cummins or Caterpillar engine beneath that hood, rebuilt once or twice across 40 years of service, often remains the most vital component in the truck. Number 7. 1970s to 1980s. Freightliner FLC Classic. Freightliner was founded in 1942 as the trucking division of Consolidated Freightways, initially building trucks for its own fleet before entering the commercial market. By the time the FLC Classic, the conventional cab version of Freightliner's flagship lineup, reached its most refined form in the late 1970s and 1980s, the company had developed a reputation for building trucks that were distinctly lighter than the competition through aggressive use of aluminum in the cab construction, while maintaining the frame and drivetrain strength needed for sustained maximum load service. The FLC Classic, powered by the Cummins Big Cam 855, became one of the most recognizable long-haul trucks on American highways through the late 1970s and into the 1980s. The combination worked because Freightliner's engineering philosophy and Cummins' engine philosophy were complementary. Reduce weight where possible, over-engineer where reliability matters, and build the service intervals and parts network to keep the truck working, rather than sitting in a shop. The Big Cam 855 in the FLC Classic produced between 290 and 400 horsepower, depending on specification, with the higher output versions available to operators who needed to maintain schedule across mountainous terrain or in expedited freight applications. The engine's demand flow cooling system was particularly well suited to Freightliner's aluminum cab trucks because it reduced the overall thermal load on the cooling system, allowing the lighter weight aluminum radiator components to handle the job effectively. One of the landmark moments for the Big Cam's reputation was the 1980 release of the 475 horsepower compound turbocharged Big Cam 2, which used a primary turbocharger followed by a secondary turbocharger in sequence to achieve boost pressures that enabled unprecedented power from a mechanically injected diesel engine. This was a significant development in an era when 400 horsepower was considered exceptional for a highway engine, and it demonstrated that the fundamental 855 architecture had headroom that its designers had built in from the beginning. FLC Classic trucks with Big Cam engines that received proper maintenance, oil changes at correct intervals, cooling system service, and injector attention regularly crossed 1 million miles on the original block. The simplicity of mechanical injection meant that any competent diesel mechanic could service the engine in the field, reducing downtime to hours rather than the days that electronics failures could impose on later generation trucks. This combination of reliability and serviceability is what made the FLC Classic with the Big Cam 855 one of the defining truck and engine combinations of its era. Number 6. 1968 to 1986 International Harvester Transstar. International Harvester's Transstar was the company's flagship conventional Class 8 tractor through the late 1960s, 1970s, and into the 1980s, a period when International was one of the dominant forces in the American heavy truck market. The Transstar, offered in both short hood and long hood versions, was known for its rugged construction, broad engine availability, and the kind of straightforward serviceability that made it a preferred choice for fleets running diverse duty cycles across multiple geographic regions. The Transstar was available with both the Cummins NTC 855 and the Detroit Diesel 8V71. Two very different engines with very different character, but equally legendary reliability records. The Cummins NTC 855 brought its proven inline-six architecture and massive low RPM torque. The Detroit Diesel 8V71 brought something entirely different, a two-stroke V8 diesel with a characteristic high-pitched exhaust note that became one of the most recognizable sounds on American highways during this era. The Detroit Diesel 8V71 was an 8-cylinder two-stroke diesel displacing 567 cubic inches, approximately 9.3 liters. Two-stroke diesel operation means the engine fires on every downstroke of the piston rather than every other, which produces a distinctive power delivery character, strong torque at relatively high RPM compared to four-stroke competitors, and an exhaust note that veteran truckers still describe with unmistakable fondness. The 8V71 produced between 270 and 318 horsepower in highway truck applications, numbers that were competitive through the 1970s. What made the 8V71 legendary was its durability under sustained load. Detroit Diesel had been building two-stroke engines for commercial and military applications since the late 1930s, and by the time the 8V71 was powering Transstar highway tractors in the 1970s, the design had been refined across decades of hard service. The engine's power delivery characteristics, particularly its strong mid-range response, made it well suited to the variable terrain, variable load conditions of cross-country freight operations. International Harvester's Transstar cab was a practical, functional design, built around the operator's need to work long hours in relative comfort, while maintaining access to the mechanical systems for roadside service if required. The truck was never the most glamorous option on the lot, but it was trusted by fleets that measured value in uptime and cost per mile, rather than in chrome and long hoods. Transstar trucks from the 1970s, powered by 8V71 engines, are still found working today in specific vocational applications, their two-stroke exhaust note announcing their presence long before they come into view. Number 5. 1965 to 1990, Mack R Model Superliner. The Mack R Model deserves a second chapter in this discussion because the RW Superliner variant, introduced in 1977 with its distinctive large rectangular hood and grille, represented the most powerful and most capable expression of the R Model philosophy, where the original R Model was built around the 675 cubic inch Maxidyne. The Superliner was engineered to accommodate Mack's larger END 676 and, later, the massive END 865, an 864 cubic inch 14.2-liter turbocharged inline-six that was among the most powerful mechanically injected diesel engines offered in a production highway tractor during its era. The Mack END 865 produced up to 350 horsepower in its highway configuration. With torque characteristics consistent with the Maxidyne philosophy, peak torque delivered low in the RPM band with a wide flat torque curve that kept the engine in its power range across the broadest possible driving conditions. In logging applications in the Pacific Northwest and in heavy-haul tandem configurations in the oil patch states, this engine became the standard against which operator expectations were set. What distinguished Mack's approach to engine reliability from competitors was the company's philosophy of building the entire drivetrain, engine, transmission, and rear axle from a single manufacturer, while Kenworth and Peterbilt offered customer-chosen combinations of Cummins, Caterpillar, or Detroit diesel engines with Eaton-Fuller transmissions and Dana or Rockwell axles. Mack built its own engine, its own Maxitorque transmission, and its own rear axles. The integration of these components, designed to work together from the beginning, produced a drivetrain with no compatibility compromises and no weak links introduced by mismatched engineering tolerances between suppliers. The Mack Gold Dog emblem, worn only by trucks with Mack's own engines and transmissions, became a mark of distinction among drivers and fleet managers who understood what it represented. A truck wearing the gold dog had a powertrain where every component had been designed to complement every other component, and that integration showed in the durability results. Mack R Superliner trucks from the late 1970s and 1980s with original Mack engines and transmissions regularly ran well past 500,000 miles before requiring internal engine work, and many examples exceeded 1 million miles in vocational applications where the engine was cycled heavily and continuously. Number 4. 1970s to 1980s, White Road Boss. White Motor Corporation was one of the oldest names in American commercial trucking when it introduced the Road Boss series, a long-hood Class 8 conventional tractor that competed directly with Kenworth, Peterbilt, and Mack. Through the 1970s and into the 1980s, White trucks were known in the industry for solid over-engineered construction and for offering the Cummins Big Cam engine in its most refined and capable configurations. The Big Cam 3, introduced in 1982, and the Big Cam 4 that followed, represented the culmination of 25 years of development on the 855 cubic inch architecture. The Big Cam 3 brought significant refinements to the combustion chamber geometry, the fuel injection timing, and the cooling system design, producing engines that were simultaneously more fuel efficient and more reliable than their predecessors. The Big Cam 4, the final and most developed version of the 855 family, produced up to 400 horsepower in standard highway configuration, and was widely regarded as the definitive expression of what a mechanically injected, large-displacement inline-six diesel could achieve. White Motor Corporation filed for bankruptcy in 1980, and its truck manufacturing assets were eventually absorbed into the Volvo-White joint venture, which produced trucks under the White GMC and later WCA, White Consolidated, brand names through the mid-1980s. But the Road Boss trucks built before and during that transition period, powered by Big Cam 3 and Big Cam 4 engines, represented some of the most durably built highway tractors of the entire era. Owners of White Road Boss trucks routinely reported that the truck's frames and cab structures outlasted multiple engine and transmission rebuilds, a testament to how heavily White had engineered its chassis. The Big Cam engine beneath the long hood needed oil changes, coolant service, and injector maintenance, and very little else to continue operating reliably for hundreds of thousands of miles. The combination of White's frame engineering and Cummins' engine reliability created a truck that simply refused to stop working. Number 3. 1960s to 1980s, GMC Astro 95. The GMC Astro 95 was one of the most distinctive cab-over engine tractors in American trucking history. Introduced in the late 1960s and produced through 1987 when Volvo AB purchased a majority stake in GMC's heavy-duty truck line, the Astro 95 combined bold, modern styling, reportedly with input from designer Larry Shinoda, with the kind of practical engineering that made cabovers a dominant truck type on American highways throughout the 1970s. Cabover engine designs were popular in this era because of federal length laws that restricted the overall length of tractor-trailer combinations. A cabover tractor, with the driver sitting directly above the front axle and no hood extending ahead of the cab, could use more of the legal length for trailer rather than for tractor. This made cabovers the economically rational choice for fleets running at maximum legal length. The Astro 95 was powered through much of its production life by Detroit Diesel's two-stroke engines, specifically the 671 inline-six through the 1970s, followed by the 6V92 V6 from 1979 onward. The 671 was a 71 cubic inch per cylinder, six-cylinder, two-stroke diesel, displacing a total of 426 cubic inches and producing approximately 238 horsepower in its naturally aspirated highway configuration. The engine's two-stroke operation with its characteristic mechanical clatter at idle, transitioning to a high-frequency drum at highway speed, was the sonic signature of American trucking through the entire 1970s decade. Those familiar with the sound know it immediately and never forget it. The Detroit Diesel 671 had been in production since 1938 in various applications, military vehicles, buses, industrial equipment, and marine vessels, and by the time it was powering Astro 95 highway tractors in the early 1970s, it had accumulated decades of engineering development and real-world refinement. Mechanics across North America knew the engine intimately. Parts were universally available. Troubleshooting was straightforward. The two-stroke design meant more power strokes per revolution compared to a four-stroke engine, which translated to strong power delivery from a relatively compact displacement. The 6V92 that replaced the 671 in the Astro 95 from 1979 was a two-stroke V6 displacing 552 cubic inches, producing between 275 and 350 horsepower depending on turbocharging and configuration. Like the 671, the 6V92 brought Detroit Diesel's decades of two-stroke development to highway service, with all the reliability advantages that accumulated industrial and military experience provided. Astro 95 trucks powered by 6V92 engines were known for their ability to maintain highway speeds under full load without the thermal stress that pushed other engines toward premature wear. Number 2. 1976 to 1988. Cummins Big Cam, 2 in the Peterbilt 359 and Kenworth W900A. It is impossible to discuss the heavy-duty trucks of this era without dedicating a full chapter to the Cummins 855 Big Cam 2, specifically the version introduced in 1979 that more than any other single engine defined what million-mile reliability meant in the Class 8 trucking world of the late 1970s and 1980s. The Big Cam 2 arrived in 1979 with a reduced rated speed of 1800 RPM, down from the 1900 RPM of the original Big Cam, while maintaining rated horsepower output. This was not a compromise, but a deliberate engineering decision. Lower operating speeds mean less internal wear per hour of service, longer bearing life, longer camshaft and follower life, and a longer interval before the engine needs any internal attention. The Big Cam 2 also brought refinements to the demand flow cooling system, which directed cooling fluid precisely to the cylinder head areas experiencing the most combustion heat, rather than flooding the entire block, reducing thermal cycling stress on critical components. By 1983, the Cummins 855 Big Cam was the engine powering 63% of all Class 8 trucks sold in North America, up from just 29% of the market in 1975. That market share was not achieved through advertising or dealer incentives. It was achieved because owner-operators and fleet managers who had run Big Cam engines reported results that no competitor could match. Engines crossing 700,000, 800,000, and 1 million miles, with nothing more than scheduled maintenance and the occasional injector replacement. In an industry where downtime is lost, revenue measured in thousands of dollars per day, that reliability record was the most powerful sales tool imaginable. The 1980 release of the 475 horsepower compound turbocharged Big Cam 2 was a landmark moment for the entire heavy truck industry. Using two turbochargers in series, a primary and a secondary, Cummins extracted an additional 75 horsepower from the same fundamental 14-liter architecture that had been producing 400 horsepower in standard configuration. This demonstrated headroom in the design that competitors lacked, and it gave owner-operators running premium loads on tight schedules the power to maintain speed in mountain grades without downshifting and working the engine beyond its comfort zone. The Big Cam's unit injection system, where each injector is actuated directly by the camshaft through a rocker arm, meant there were no high-pressure fuel lines to crack, no common rail to fail, and no fuel pressure regulator to malfunction. Each cylinder's fuel delivery was mechanically independent, which meant a single injector issue affected only that cylinder and could be repaired individually without affecting the entire system. This architecture was brilliant in its simplicity and devastating in its durability. Drivers who ran Big Cam 2 engines in Peterbilt 359 trucks and Kenworth W900A trucks through the 1980s describe the experience in terms that go beyond mechanical admiration. The engine had a presence. At highway speed, under load, it operated with a deep, rhythmic pulse that felt like the mechanical heartbeat of something genuinely indestructible. That feeling was not just subjective. It was the physical expression of an engine operating well within its structural limits, with reserves of strength that no road condition, no load, and no weather could fully exhaust. Number 1. 1967 to 1985. Peterbilt 359 plus Caterpillar 3406. The Caterpillar 3406 engine, introduced in 1973, is the number 1 engine on this list, not because of a single superlative statistic, but because of the totality of its record across every dimension that matters in commercial trucking: raw durability, power delivery, field serviceability, fuel efficiency for its era, and the sheer accumulated mileage documented on original or minimally rebuilt blocks across thousands of working trucks. Caterpillar entered the on-highway diesel market in the early 1970s with an advantage no other engine manufacturer possessed: decades of engineering experience building diesel engines for construction equipment, mining machinery, power generation systems, and agricultural equipment, all applications that demanded maximum durability under sustained maximum load operation in harsh environments. The 3406 brought all of that industrial engineering DNA into a package dimensioned for highway truck service. The 3406 was a 14.6-liter turbocharged inline-6 diesel with mechanical fuel injection. In its earliest highway configurations, it produced around 350 horsepower and 1,250 pound-feet of torque. Competitive numbers for 1973, but more importantly, numbers produced at conservative engine speeds that left enormous structural margin in the rotating assembly, the cylinder heads, and the valve train. The bore measured 5.4 inches and the stroke 6.5 inches, giving it an under-square design, a longer stroke relative to bore, that produced torque at low RPM rather than demanding high engine speeds for peak power. The mechanical injection system used by the 3406 was Caterpillar's own proprietary sleeve metering design, which the company had refined extensively in its construction equipment engines. This system delivered fuel with precision and consistency, producing uniform combustion across all 6 cylinders, minimizing the hotspots and thermal gradients that cause premature head and gasket wear. Caterpillar's metallurgy for the 3406 block was derived directly from their construction equipment standards, a domain where an engine failure could mean a $500,000 excavator sitting idle on a job site. That standard translated directly to exceptional durability in highway service. The Peterbilt 359, when fitted with the Caterpillar 3406, was considered the definitive truck and engine combination by a significant portion of the owner-operator community through the late 1970s and early 1980s. The 359's long hood accommodated the 3406's cooling requirements without compromise, and the truck's heavy-duty chassis provided a stable, vibration-dampened foundation that reduced stress on the engine mounts and external components. Owner-operators who invested in this combination and maintained it properly documented engine lives that are, even today, remarkable. Mechanics who specialized in 3406 engines during this era reported that the engines were almost uniformly in serviceable condition at 500,000 miles, requiring nothing more than injector service and timing adjustments. At 1 million miles, properly maintained 3406 engines showed cylinder wear measurements that still fell within factory-acceptable specifications, meaning the fundamental bore geometry had held tight through a decade or more of continuous service. These are not anecdotes from enthusiasts. These are documented service records from commercial fleets that measured engine performance against financial results. The Peterbilt 359 was discontinued in 1987. Replaced by the Model 379, which would carry the Caterpillar 3406 forward into a new era in an even more refined combination. But the 1967 to 1987 production run of the 359, and specifically the decade-plus pairing of the 359 with the mechanical 3406, represents the apex of the 1960s to 1980s golden era of American heavy-duty trucking. It is the combination that established the benchmark. It is the truck and engine that every subsequent design was measured against. And it is the combination that, when you find a maintained example today, still starts in 10 seconds, still pulls its rated load, and still sounds exactly like what it always was, an engine built to run forever. So that's it for today. If you like this video, then please hit the like and subscribe button for more videos. Thanks for watching.